All right, welcome back, my seventh graders. Let's go ahead and knock out 7.1 out of all the odd ones. So create an appropriate data display to represent the data. I see that 4 is by itself in all this data, but it looks like 6, there's 2 of those, 1, 2, 3 8s, 2 10s, even 2 5s. If I was going to do this, I think I would be okay with a bar graph. So I would go ahead and hit a bar graph there, and this would tell me that I would have 1, 4. Let me see, 4 goes up to 1. And then it should be 2 5s, 1, 2. And it would be 2 6s, 1 7, 3 8s, 1, 2, 3. So that goes to 3. 1 9 and 2 10s. Okay. Um, let's go ahead and do this next one where it says write and solve a proportion to answer the question. Okay. If I'm writing and solving a proportion to answer the question, it says what is 25% of 64? I remember I can always go ahead and let's see, make 2 fractions, right? And the minute they said 25%, I can put my 100% on the bottom of this and put 25 above it. Remember, these are equal to each other, and this is a percent. And this is of 64. The ofs go on the bottom, and the is's go up on top. Since there is no number with is next to it, we're going to make this x. So if I'm solving this, and I'm just going to do the work up here, this would be 64 times 25. And that would have to equal 100 times x. Well, I got to figure out what 64 times 25 first. Get my calculator out here. I see that 64 times 25 equals 1,600. And that's going to equal 100x. I know to get x by itself, I have to divide 100x by 100. And that leaves me x all alone. And whatever I divide from one side, I do the other. Remember, there's a 0 on top and 0 on the bottom, and cross them out. I have 16 over 1, so that means my answer has to be 16. So what number is 25% of 64? 16. All right, going to number 5. Find the sum. Got to add these up. I'm going to combine my like terms. Since this is a positive, I can take these numbers and put it over here. Now I have a negative 5x over here. And I have negative 2 over here. Put a line under both. 4 minus 2 is 2. And since the bigger number is positive, be a positive 2. Remember, my signs are different. I find the difference. Take the big number minus the small number and keep the sign of the big number. Now, if 3x minus 5x, again, we take the big number. This time it's 5 minus the small number, which is 3. That's going to leave us 2. And since we're talking about x's, that's going to be 2x. We keep the sign of the bigger number, and the bigger number was negative 5, so that's a negative 2x plus 2 as my answer. Okay. All right, let's move on. Go on to number 7. Finding measures of center variation. Find and interpret the measures of center and variation of the data. Okay. So if I'm interpreting the measures of center, first, if I'm going to find the median, I know I'm going to cross all of these out, which means I can see how many there are. 1, 2, 3, 4, 5, 6, 7, 8. That means there's going to be 4 on one side, 4 on the other, right? And since there's 3 on each side, I know that would be 3 plus 3, which is 6, divided by 2, because there's 2 numbers here, and that's going to leave me 3. So the median is 3. The mode is the number that you see most often. I see, oh, 1 second here. I did notice that these aren't in order. And remember, the rule is we have to put these in numerical order. So let me redo this answer. We've got 1, and then there's a 2 here. There are 1, 2, 3 threes. No 4s, and then a 5 and a 6. And I have to apologize, I didn't notice that there was actually 2 1s, so I'm going to put 1 1 over here. Now they're all in order from least to greatest. That's necessary. So now when I take 1, 2, 3, 4, again, the 2 3s are in the middle. That didn't change anything. My median is a 3. All right, let's go ahead and try the mode. And since 3 is the one that most often seen, that will also be 3. And then let's try the means. And we have to add all these numbers up and then divide them by the number of numbers there are, which are 8. So I have 1 and 1 is, well, I'll just start over here. 6 and 5 is 11. 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20. 20 plus 2 is 22. 23, 24. So this is going to be 24 divided by 8. And once again, as you can see, we got 3. So the measure of center is definitely 3. All right, next let's check the range. The range is the biggest number minus the smaller number. 6 minus 1 is 5, so the range is 5. And the inner quartile range, well, since this is the middle here, I'm just going to make it a different color. Try red here. Since this is the center of the data, and the center of this data here would be here, the center of this data here would be here. So let's take the average of those. I see that this is between 1 and 2, and between 1 and 2 is 1.5. So that's going to be 1.5. And this is 3 and 5, so between there is 4. And then the quartile range, that's IQR. That's going to be 4 minus 1.5, which is going to give me 2.5. All right, let's go on to number 9 now. It says find the mean, median, and mode of the data. Okay. Once again, I'll go with the median first. We've got 1, 2, 3, 4, 5, 6, 7, 8 numbers again. Once again, I'm going to have to put these in order. I think I'm going to do this over here to give me some room. So the smallest number is going to be 4. Let's see, the next smallest number is going to be, I'm just going to kind of put a yellow mark over it to remind me what's already been used. Next looks like a 7. And a 7 looks like it's in there twice. So I'm going to put 7, 7 again. And then after the 7s, there's an 8. So let's put that 8 in there. And after the 8, looks like there's a 10, 11, 12, 13. 10, 11, 12, and 13. Now, the mean, median, and mode. The mean is found by adding all these up, dividing by the number of numbers. So let's go ahead and add these up. We got 13 plus 12, that's 25. 25 plus 11 is 36. 36 plus 10 is 46. Okay, 46, let's see, 46 plus 4 is 50. 50 plus 8 is 58. And then we have 58 plus, well, 7 and 7 are 14. So 58 plus 14. 58 plus 14. That's 72. All right, so 72, and we're dividing it by 8. That's going to give us 9. So the mean is 9. All right, let's go and try the median. Remember, the median is the number in the center. There's 4 on this side, 4 on this side. Now I have 8 and 10. 8 and 10 is 18. We have to divide that by 2 because there's 2 numbers that we added together. And that'll be 9 again. So the median is 9. Now for the mode. The only number that repeats itself is 7. So the mode has to be 7. All right, so the mean is 9, the median is 9, and the mode is 7. All right, let's go to number 11 now. Once again, I got to put all these in order. This is going to be a little nightmare. The smallest number here, this is, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, okay? The first number is 5 and 1/4, and I don't see anything smaller than 5 and 1/4, so I'm going to put that there. Next, I see a 6, so actually there's 2 6s, so I'll put that next. All right, that took care of that one, and that one. Next smallest number, let's see, well, there's not a 7, there's not an 8, but there is a 9. Wait, there's an 8 and 1/2 here. Got to put that first. 8 and 1/2. And we said there was a 9 there. Now let's go ahead and look for the 10. The only 10 here is 10 and 1/2. And let's see, after 10 and a half, actually there was a 9 and 3/4, wasn't there? And I have to take that back. 9 and 3/4 is smaller than 10. 10 and a half. All right, so let's see, we got rid of the 9, 9 and 3/4, 10 and a half. The 8 and a half we got rid of. All that's left that I see are the 14 and the 12. So 12 and 14 are in. That should be 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when we're going in, we could go to the 5th number, 1, 2, 3, 4, 5. That number is 9, right? There are 4 numbers to the left of it and 4 numbers to the right. So the median is 9. Let's look for the mode really quick. I see that there's 9 and there's 6s, right? Well, actually, there's a 9 and 3/4. There's only one number that repeats itself, and that's a 6. So the mode is 6. And now, let's see, the means. I have to add up all these numbers and divide it by the number of numbers there are. Well, I'm going to do it really quick with my calculator. I know that 5 1/4 is really 5.25. I'm going to add that to 6. I'm going to add it to 6 again. Now I'm going to add 8.5. 8.5 I know is really just 8.5. And I'm going to add that to 9. I'm going to add that to 9 3/4. 3/4 is 0.75, so this is 9.75 plus 9.75. 10.5 is really 10.5, so plus 10.5, plus 12, plus 14. That gives us 81. Now we got to divide that by the number of numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're dividing this by 9. That's going to give us 9. So the mean is 9. All right, and that's all it asks us to do. So let's move on to number 13. It says stem and leaf. Okay, so what are we supposed to do here? Okay, find the mean, median, okay, mode of the data for the stem and leaf. All right. If I'm doing this for these, I have to put them in order again. Hold on. So let's put all these in order. We've got, let me try to use all this room up here that I've got to work with. First is 1 and 5, so that's 15. And then there's another 1 and 5, so it's another 15. Now we got 2 and 6, so that's 26. And then 2 and a 7, so that's 27. We got a 3 and a 4, 34. And then a 3 and a 7 for 37. And we got 43 and 48. All right, and then I'm sorry, that's 43 and 48. I don't know why I made an extra 8 there. All right, and then it's 55. Now that we have them in order, let's look for the mean, median, and mode. Well, the mean is the one that most often seen. See, 15 is here twice. 26, 27, 34, 37. Actually, it's the only one. So the mode has to be 15. All right. Let's look for the median. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So 1, 2, 3, 4. That means my median must be 34 because there's 4 numbers to the right of it and 4 to the left. So the median is 34. Sorry, that turned out kind of messy. All right, and then we have the means. Once again, we're going to have to add up all the numbers and then divide it by the number of numbers there are. At least there's no fractions this time, right? So 15 and 15, that's 30. 30 plus 26, that's 56. Plus 27, That's 83 plus 34 plus 37 plus 43 plus 48 plus 55. All right, so that's going to give us a whopping 300. All right, now we got to take 300 and divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9. That's going to give us 33.3 repeating, which is about 33 point, about 33.3. So 33.3 repeating. Doesn't say it around, so I'm just going to keep it at that exact number. All right, and that was all of that. Let's go to 15 now. The table shows the duration in minutes for several television shows. Find the mean, median, and mode of the duration of television shows. All right, let's go and put these in order again. Smallest to biggest. The smallest looks like it's maybe 26. I don't see anything smaller than 26. Now let's see, after 26, there's no other 20s, so let's go to the 30s. I see two of them that are 38. Okay. Oh, I'm sorry, there's a 28 over here. So I'm going to take this and turn it into an 8 and make this a 26 over here. Sorry about that. So now we have 26, 28, 38, and 38. Next number looks like 39, because the rest of them are on their 40s. All right, and next is 41. There's two of those. And then there'd be 1, 2, 3 42s. And let's see, let's look for the 43s. There's one, it's like only one number that's 43. And 44, that looks like there's one of them that's 44. One that's, well, two that are 45. Wow, I'm going to go off the board here, aren't I? 45, I'm just going to scroll this way. 45, so there was two of them. And then there's one that's 46. And I think that's every single one. All right, they want to know the mean, median, and mode. Wow. All right, if I'm going to do this, see there's, well, 1, 2, 3, and 1, 2, there's 15 numbers. That means dead in the middle of 15 should be 7.5. So I'm going to look for the eighth number. 1, 2, 3, 4, 5, 6, 7. The eighth number is here, which means there's 7 numbers here and 1, 2, 3, 4, 5, 6, 7 numbers here. The median has to be 42. So look for the mode, that number most often seen. 38 is done twice, 42 is done twice, but 42 is done 1, 2, 3 times. So I'm going to go with 42 as the mode. And now for the means. I have to add up all these numbers. Let's start from the biggest to the smallest. 46 plus 45 plus 45 plus 44 plus 43 plus 42 that was the first 42. We got two more to add on there. Plus 42 plus 42. All right, now there's two 41s to add on. Plus 41 plus 41. There are 139 plus 39. Oops. Two 38s plus 38 plus 38. Then 128, so plus 28, and then plus 26. That gives us 600. And remember, we're dividing this by 15 because there's 15 numbers. That's 40. So the mean is 40. All right, let's move on. Number 16, find the range and interquartile range. The range is going to be the biggest number minus the smallest. The biggest number is 19. And again, we really should put these in order. If I put these in order, the smallest number is going to be 3. Next smallest number is going to be, looks like 8. And 8 again. Then looks like 9. And then we got two 10s. And then 119. All right, so let's see. The big number is 19, the smaller number is 3. So the range is 19 minus 3, and that'll give us 16. So that's the range. The interquartile, oh my gosh, that's an even one, isn't it? Yes, I wasn't supposed to do that one. I was supposed to do this one over here. So I'm going to stop there and start on 17. I apologize. I'm going to have to put these in order. The smallest one here is going to be 9. Next smallest looks like 11. The next smallest would be 13. The next smallest looks like to be 15 and 17. And now we have 24, 25, and 27 left. 24. 25 and 27. All right, so there's one, oh, I'm sorry, the biggest number is 27. So this is 27 minus 9 to find the range. 27 minus 9 is 18. So the range is 18. And now we're going to find the interquartile range. The interquartile range is going to be, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That means 4 numbers here. The middle is here. And that means the middle of this quartile is here, and this one is here. So now we have between 11 and 13 will be 12. And between 24 and 25 is going to be 24.5. Now I have to take 24.5 and subtract 12. That's going to give us 12.5. So the interquartile range equals 12.5. All right, number 19 is next. There's a lot of numbers here. You know, you're supposed to put them in order from smallest to biggest. Again, you'll take the biggest number minus the smallest number. The biggest number looks like to be 93. And the smallest number looks like to be 8. So when I take, let's see, 93 minus 8, it'll give me 85. And I put this over here because this video is getting kind of long and I want to shorten it up a little bit. The range will be 85. Then you'll do the same thing we did over here, find those middle ones, and you'll find out the interquartile range will be 57. All right, let's go to number 21. During this one, we can tell right now the middle of the data is going to be 61. So this one's, you can see that having this box and whiskers makes this pretty easy. 61 is your, oh, actually, they wanted the range. I take that back. Looks like the dot is here. I don't see anything over here, which is very strange. I'm feeling like I'm missing something. I'm going to go check. It turned out I'm not missing anything. As weird as this looks, I'm going to have to go and work with it. The range is the biggest number, which is 67, minus the smallest number, which is 53. I love the way the box and whiskers makes it very easy to see everything, so it's already in order. 7 minus 3 is 4, and 6 minus 5 is 1. That means the range is 14. All right, and then we have the interquartile range. That's going to be, well, this is the third quartile, so that'll be 67 minus 57. 67 minus 57 is 10. So that means the interquartile range is 10. All right, let's go ahead and move on. So what are the range and interquartile range of the data set? Okay, so they gave us a set here. Again, they're not in numerical order. So I got to put them in order. If I do, I'm going to say that looks like 13 is the smallest number here. Oh, I'm sorry, this was number 22. That's for you to do. I'm doing number 23. The table shows the height in inches of players on a basketball team. Find the range and interquartile range. Again, we'll have to put these in order. Looks like 68. Yes, 68 looks like the smallest player. Then let's see, next would be 69. Let's see, after that, looks like we're in the 70s. I don't see a 71, so we're going to go, there's two 72s. I don't see any other 72. I don't see a 73 or a 74. Looks like the next one is 75, and there's 1, 2 of those as well. Well, I'm sorry, there is a 74 here. Let me take that back, put 74. And then the two 75s. That takes care of them. Next is 76, 77, 78. All right. There were two 75s, yeah. So yeah, 76, 77, 78. And because there's 3 and 4, there should be 12 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Uh-oh. How many 75s were there? 1, 2, I don't see another one. Let's see where it didn't count right here. 68, 69, 70, 72, 72 again, 74, 275s. Oh, there should be 276s. Look at that. I didn't see that one there. So let's fix this. And then put 77 and 78. Now there should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's find, it says that range, the range is the biggest number, 78. And we're going to minus 68, and that leaves us 10. So the range is 10. Now we got the interquartile range. We're going to be splitting this up. Since I know that there's 1, 2, 3 times it, that's 12. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6 on this side. That means it's right in between 74 and 75, which is 74.5. Right? When I do this now, I got to find the middle over here. That middle is going to be, well, 1, 2, 3, 4, 5, 6. So 3 on each side. And between 70 and 72 is 71. Over here, we got, see, 1, 2, 3. So the middle is going to be right there. In between 76 and 76 is 76. So this is going to be 76 minus 71. And that's 5. So the interquartile range is 5. All right, let's go to number 23. Sorry, 25. Identify any outliers. Outliers are those numbers way away from all the rest of them. I got 13, 9, 14, 22. Now, 22 is definitely not close to any of these numbers. I'm going to have to say, oh, and 3. Yeah, okay, I'm going to say that 3 and 22 are outliers here because 3 is away from a lot of them, and so is 22. Now, if we have to narrow one down to the other, I would say since the nearest number to 9 from 3 is 6 away, right? 9 minus 3 is 6. But 22 from the next biggest number is 14. That would be 8 away. So if I had to pick between 3 and 22, I would go with 22. But I'm kind of thinking both of these are outlying away from the data, 22 more than anything else. All right, let's go to number 27. Again, where are the outliers at? Well, these are on the 30s. These are on the 40s. These are in the 50s. There's only one that's in the 60s right here. That's 63. I'm kind of feeling like 63 is going to be my outlier here. I could probably say 57 as well because these two are pretty close. Right? But 63 more than anything else. And I did want to point out something. I noticed over here on the key it says 3 and then line 2, but went 3.2, which means there's going to be a point in between each of these numbers. So it's really 5.7 and 6.3. These would be my outliers. All right, number 29 is next. 29 says Mako is a steel roller coaster, okay, at SeaWorld in Orlando. The data set, which is here, represents the number of people who ride Mako each hour for a given day. Identify the outliers. What would my outliers be here? Well, 220, 220, right? 240, 160, 220, 230, 244. I know that 244 seems really high compared to these over here, but really it's only about maybe 6 away, right? I guess it could be 244 minus 28 might be 16. But over here, this 162, that's going to be from the lowest number, which is 221. That's going to be quite a bit away. It's almost, wow, almost 40. So I'm going to go with 162 as my outlier here for number 29. All right, let's go down here for number 31. It says identify any outliers in the box and whiskers plot below. Remember, outliers are those things way away from where the majority of the data is. The majority of the data is sitting between around 23 and 25. This 19 and this 29 are definitely outliers. They lie way away from the numbers that are over here. Number 33, what measure of center of variation, if any, can be found given a histogram? Given a histogram, and we vaguely went over this in class. There are none. Histograms do not show exact data values, so you cannot calculate exact values for measures of center of variations. So no. Let's go to number 35, our last one. Can the range and the interquartile range of the data set be the same value? If so, give an example. If not, explain that. And the answer to that is yes. If all the value is the same, right, I could have my range is 5 minus 5, which is 0, and then my interquartile range would be 5 minus 5, which would also be 0, right? So in this case, where all the numbers are the same, yes. All right, that's it. Sorry this video took so long, but I hope it helped you to figure out how to find the mean, median, and mode, range, and interquartile range. Have a great day, and I'll see you for grading in class.